So I am Tony Forelli. I'm VP of Operations at Catchpoint. So my background is I'm a network engineer. So I started back in '94 at AT&T before they even had a backbone network. They were reselling BBN Planet's backbone, right? And did that for a couple of years until they finally built out their infrastructure and we were able to sell our own backbone at that point. From there, I moved to a company called DoubleClick, which was internet advertising. And from there, I spent 12 years at Google, where I worked on edge CDN stuff and peering. And then I also worked on the enterprise side for 3 years on the Wi-Fi side of the house. Okay, so total experience of observability with Catchpoint. Observability is this big marketing term that's out there. I'm not sure who actually 100% understands what it means at this point, right? But what it is about is measuring lots of things.
It means you're trying to say monitoring.
Exactly. It's the new word for monitoring. But you're trying to measure more things from different perspectives, right? And we'll talk a bit about that in a few minutes. This is just our mission to empower teams to own the digital experience of their users by providing unparalleled visibility and insight into their complex digital ecosystems, right? So this is like a little bit of a change of a philosophy, right? I think we have all heard network is slow, right? We help you prove that the network is not slow, right? Or if it is the network's fault, we help you figure out where that's happening. So I'll just start with the money shot. This is our node network, right? We have over 1,000 nodes globally around the world that are basically
exactly 1024.
Well, I mean, we timed that one a little bit. The number's actually 1040 right now. So it's gone a little up in the past week and a half since this slide was made. So it's a little bit higher, but 1024 seemed too perfect to pass up. So there you go. We're in 88 countries, 320 providers. This is on the synthetic, the black box monitoring portion of what we do. And then BGP wise, we'll talk a little bit about that later, but we have an extensive BGP collection of route tables that we bring in, and then we help analyze for you guys, right? I think we all started in this and we all monitor our infrastructure, and this is just taking a new approach to the problem, right? We all monitor our infrastructure. We monitor our network with SNMP or streaming telemetry. The applications guy do their magic. The system admins do their magic, right? What we're saying here is you have to approach these problems in a new way. As applications on the internet get more complex, and even within your own space, you kind of have to take a different approach to the problem and look at it from a different perspective. All this stuff is still good, right? This stuff is not going away. I want to know what my interface stats look like, right? When I'm looking at my routers and switches. But that's not a complete picture as to what's going on. And we want to help you get that complete picture. So the way we approach the problem is in a bunch of different ways. These are basically these black box monitors that I talked about. These are the black box monitors that we place all over the world, but we also can monitor stuff from user laptops and workstations. And then we also have browsers, right, that we can look at, and that's through RUM data, right? So that's like JavaScript placement on a website to actually measure things. So we have different approaches and different ways that you can look at these things, because again, this is about perspective. We want to give you multiple perspectives to be able to look and analyze a problem as it's coming in, so before your customer knows, right? Because the last thing you want is your customer complaining to you, because if you're on the network engineering train, you're not in direct contact with those customers. It might take a while for that problem to filter down to you, right? And that time is money. This is just about applications are just so complicated nowadays. MEC is now in the mix. Do you all know what MEC is and what it's supposed to do, right? This is mobile edge compute. This is people putting compute closer to the end users. Wow, wild concept. But it's not just about content and CDN content anymore. It's about microservices, right? Put services that need low latency closer to the user so they get a better experience. But what that does, it really complicates everything that's happening in that application food chain. That's why it's important to monitor things from the user perspective, right? And we don't just do stuff from the user perspective too. Like you can look at APIs, you can look at multiple things, but stuff is getting more complex out there. And it's really important that cloud doesn't solve all the problems, right? everybody thinks, oh, well, I could just spin it up on Amazon and I don't care about the network anymore. But that's not true because there's so many components that are a part of this. And I think the next slide kind of illustrates it, right? You're one application. You got people coming at you from so many different directions now, right? There's so many providers in the mix from a last mile perspective, backbone perspective, DNS, CDN, third-party services. I mean, just the other day I was looking at like CNN.com, and there was probably like 30 IP addresses you connect to, right? When you go to CNN.com, because there's so many third-party applications that they tag their site with, whether it's Google Analytics or some other marketing thing, right? There's so many things in there. So when somebody comes and says the site's slow, somebody has to discern, is it me? Is it the network? Is it that guy? Is it that guy? Right? So there's so many fingers that can be pointed. You want to make sure that you have a system that helps you figure out where does the finger need to go and who can fix this problem? Because I don't care about the finger pointing part of it. I want to fix the problem so it's not impacting my users. You know, and so this gets into like, really, I just want to focus on the personas here, right? Like we have different users that use us in different ways. We have network engineers that use us just for that visibility. So the pings, the trace routes, slowness, BGP, stuff like that. But then we have SRE teams that actually care about APIs and the speed of an application. We have DevOps folks that use us to actually design their websites to see, hey, is this the most efficient way to put it out there? You know, IT ops use us, right, to troubleshoot problems, right? Like talking about that laptop desktop component, right? CIT, corporate IT folks actually have a hard problem to solve now, especially in this work from home environment. It becomes really, really hard for them to figure out what's happening on that person's system. We want to help give them that visibility. And this is just some of the folks that we work with. Like I said, different folks use us for different things. You know, some will look at us, you know, like one of these brands here was interested in China. We have like over 80 nodes in China, mainland China today. They wanted to do research about who's the best CDN, what DNS provider, how should I set up my DNS? What co-location should I look at? Where should I host my support, right? And they can look at that because we give them a unique perspective, you know, where we look at like individual regions, individual ISPs within that country that they can go work with in the future. So the next step is we're going to talk a little bit about the node networks because that's what my team manages. This is how we build it. This is how we manage it. And I want to give you that unique perspective. And again, perspective matters, right? If you're looking at the problem from one perspective, you're never going to solve. You may solve that problem, you may not solve that problem. But what you want to do is you always want to have a different angle of attack, right? So you can figure out what's going on. And I just like some of those representations. This is just what our global node networks looks like. You can see we have heavy presence in North America, Europe, China, Australia. We're building out faster. Right now, we're working a lot in Africa, right, to improve our presence there. And this is what we care about, right? So when our public node network, and then keep in mind, the thing I didn't mention before is you could take any of our public nodes and you can make it private and put it inside your own data center. You could put it inside your own corporate office, right? And run all these tests that we'll talk about in a few minutes from anywhere, right?
So the RUM and synthetic transactions, you can do that from behind the firewall in China?
So RUM transactions is actually a tag that sits on like somebody's website, right? So you have an e-commerce site, you put a RUM tag, and in theory, it should work from China depending on the Great Firewall, but we actually have landing stations for that within mainland China.
Okay.
Yeah. So hopefully you don't lose that data. And that data is super valuable, right? It's giving you that applications perspective, right? That specific site that you're going to. But I mean, that data along with NetFlow data is actually super interesting, right? Because now you can see where your users are coming from and start to plan your network around that. So from our public node perspective, right, we have what we call backbone nodes. It's a little bit of a misnomer. You know, so when we go into a market, we're looking at tier 1, tier 2, and tier 3 ISPs, right? So, and I'll talk about that in a few minutes. Cloud nodes, we're on every major cloud provider, including some of like the smaller ones out there now, like Naver, who is just up and coming in Korea, right? Because again, everybody's running their applications in the cloud, or not everybody, but a lot of folks are starting to do that. So we wanted to make sure we represented those perspectives. Wireless nodes, so we run our own 4G and 5G nodes that sit behind like a Cradlepoint or a Peplink or cellular router. But then we also just started standing up AWS Wavelength, and that's the MEC stuff that I was talking about before. So what Wavelength's doing is they're actually hosting stuff inside of Verizon Wireless's network. It actually sits on their AS, right? And that's really hard to do. You can't get a private connection to Verizon Wireless unless you're special. This actually gives you that point of presence. It sits at their edge, but it's still representative of what Verizon Wireless's network perspective looks like. They also are with KDDI in Japan, SKT in Korea, and Vodafone. They just opened up a few nodes in Europe, right? So they're starting to grow. Google and Azure are doing the same things, right? They're working with these carriers because they want to go deep. They don't want to just be at the edge at some point. They want to be at the cell tower, right? And those perspectives are things that we want to give you guys as you plan out, you know, where do we need to be? How do we make this thing faster, right? How do we accelerate what can't be accelerated because of speed of light problems? So getting it closer to the user is super important. And then the last one is we have 116 last mile nodes. So these actually sit in people's houses. So we give somebody a bunch of compute, usually like an Intel NUC or some sort of device like that. We have an appliance that sits in their house and can run all these measurements. So when we go into a market, we don't want to be multi-homed, right? And I'll show you that, guys, that in a second. That's super important. We always do IPv4 and IPv6 nodes. So we have dedicated v4 and dedicated v6. And the reason is, you know, even though we're moving into this v6 world, a lot of people are still far behind, right? So we want to make sure that you can do that comparison, and you'd be surprised, large bulk of customers are still on v4.
Doesn't surprise me.
And it makes me sad, but you know, it doesn't surprise me. And then like I said, there's other sources. We have RUM. You know, we do, you know, I use some AppNic lab tables, route tables. This is the way we decide who we're going to peer with where. Or not peer with, I should say. We buy transit. These are all the different application tests. So we run a full version of Chrome browser within our agent software. So people can script things like logging into a site, searching for something, putting it in a shopping cart, buying it, and then logging out. And we measure that full transaction and break it down into all the microtransactions that happen there. So that means all the third-party stuff that gets called, everything is in there and exposed, and we measure the times for it all, right? So you want to see TCP wait times for some Google Analytics tag, you can go find that in this data, right? But then we get super specific too, right? So SSH, streaming, API transactions, because like I said, everything's breaking into microservices now, so monitoring APIs becomes super important. Simple HTTP, like curl, wget type stuff, DNS checks. You'd be surprised how many people forget about how important DNS is and how important DNS slowness is into your applications. You can do custom TCP and UDP ones, monitors also, and then normal network stuff, traceroute, jitter, BGP, ping, iPerf, jitter, you know, and that's on the private nodes that you can do iPerf because we can't allow that on the public side. And we can do it from access networks like Wi-Fi. So this is a little bit more about the philosophy I was talking. We don't like to multi-home. So when we go into a market like LA in this case, right, I will stand up individual nodes on AT&T, individual nodes on level 3, individual nodes on Comcast. So what we'll do is we'll look at the top providers in that market. We'll go after the tier 1s, we'll go after the tier 2s. And if we can get some of the tier 3s in the data center that we're in, bring them on, right? Because we want to give you that perspective of what AT&T looks like, right? What performance looks like from their perspective. And you'd be surprised on how that matters. So Show you some graphs. So this is just a visualization. If you're a multi-homed and we had multiple providers and we weren't controlling that upstream provider, a problem might happen on they're peering with level 3 or their transit with level 3, but it might get masked because they might move us off of that and move us to AT&T or Verizon or whomever. We want to catch that problem. We want you to know when Comcast is having a problem in the Northeast, that our nodes are part of that Comcast network. We get our IPs from them, right? We make sure that we get, so that was the other point I should have made before, is we make sure that we get our IP addresses from their space. I want their space in that market because when they have issues, I want to know about it. I also want that geolocation data to be accurate because I want them to tell me where they are. So when a CDN provider comes and partners with us and they want to use us to double check things, they know that they can trust that that IP space comes from the right location in the right city. This is just a pretty trace route that you can see. So you can look at it from multiple perspectives. You can look at like a single location over time and see the different paths that it takes, right? Just within the tool itself. So think of this as like an expanded looking glass that's dedicated, so not the BGP portion of it yet, but what you get is the ability to run pings, trace routes continuously from any of these locations, but then you can also do them on demand. And you can make it an API call if you want, right? So something triggers on your monitoring, you want to do a double check, you can trigger a bunch of events to happen on our system via APIs. So this is a multi-home. This is a perspective from our CEO's house where there was a problem. This was the multi-homed look, right? This was going to one of the major cloud providers. But when you broke it down, only Telia was actually really having a major issue in that market. But without this data, how would you figure that out? And actually, just last week, we had a case in India where Vodafone was actually blocking access to 2 resolvers. So every other node in India was fine, except Vodafone throughout India, they were blocking access to two of our customers' resolvers, and then nobody knew why. But without that data, without that breakdown, it made it really easy for them to find, get in touch with Vodafone and fix the problem, right? And Vodafone's answer was, well, there was some DOS thing happening, so we blocked access to those 2 resolvers, right? But without having all the data, and Zach's going to show you more on this in a couple of minutes, that you can actually dig into that DNS data and actually see what's going on. And it would have pointed the finger saying, hey, it's not just broke. DNS broke it. This was just an interesting thing that we that we looked at for these sites, and you can see cloud versus backbone. So we have cloud. So one of the things I mentioned before is we stand up nodes on every cloud region. So when Amazon opens up a new region, a new metro, a new local zone, we stand up nodes on it. Because this way you can run your own verification to make sure that Amazon is doing what they say for inter-region transfers, right? And then these nodes are actually really nice. Cloud nodes are actually really nice for verifying numbers, right? Doing SLA reports against, right? Because they are multi-homed. I know some of the network engineers that work on the Google side. I know they're really good, and I know they route around problems as soon as they realize that they're there. But the interesting thing here is if you just look at cloud DNS versus backbone DNS, the other thing that we do on our nodes, we run our own resolver. So our nodes run their own resolver because cloud nodes use a shared resolver. So their times are going to be better because their TTLs are probably always getting refreshed. Whereas on our nodes, if it's a fresh domain, every time, and it's like, let's say it has an hour TTL and you're running a test every 15 minutes, every hour, you're going to see that TTL is flushed, and you're going to have to go through the full authoritative, root name server, authoritative, blah, 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 right? Because we want you to be able to see that and be able to see the impact some of your decisions are making, especially from a DNS perspective, on how things are performing. So it's really important for us to pull that stuff out and not rely on like 8.8.8.8 or 1.1.1.1, right? Because those are kind of giving you a false sense of security that everything's fine.
Does no one use 4.2.2.2 anymore? Come on.
That was MCI, wasn't it?
And again, this is just another picture of the node network.